All right, so thank you everybody for joining us tonight for our first speaker series of, well, actually our second speaker series event of May in our Wildfire Awareness sort of month campaign that we have going on with Casca and Desert Defenders. My name is Ani Quiros, and I am the engagement coordinator for the Central Arizona Conservation Alliance. And we're really glad to have you folks here. Like I said, the entire month of May, we're going to be focusing on all sorts of wildfire topics, whether it's prevention, invasive plant species, the role of fire in the Sonoran Desert in general and in the Southwest, which we'll be hearing a lot about tonight, and a whole bunch of other topics that, so you can find all of that cool stuff on social media. Of course, please join our other speaker series. But really excited to have you all here. We are the Central Arizona Conservation Alliance, and we're an initiative of Desert Botanical Garden. Just a few housekeeping notes before I introduce Dr. Hunter. Please keep yourself muted as always. And of course, if you have any questions throughout the presentation, you can definitely put those into the Q&A portion or in the chat. In the chat, you have two options to send a question to panelists or to the panelists and all the attendees. So, you can pick whatever option you like best. We will be getting to your questions at the end of the presentation. And so without further ado, I'm going to introduce Dr. Hunter. Molly Hunter. Dr. Hunter is an associate research professor in the School of Natural Resources and the Environment at the University of Arizona. Her main duty is to serve as the primary science advisor for the Joint Fire Science Program, which is a partnership among the U.S. Forest Service and the Department of Interior that funds scientific studies that inform wildland fire management. Dr. Hunter also serves as a research manager for the Southwest Climate Adaptation Science Center, which is a partnership between several academic institutions and the U.S. Geological Survey that really advances science to support the adaptation of natural and cultural resources in the Southwest to climate change. So we're very excited to have her here to talk to us about the role of fire in Arizona ecosystems. And so I'm going to go ahead and hand it off to Molly, and we're really excited to have her here. So thank you so much for joining us.
Great, thank you. Yeah, it looks like you have to make me host again.
One second. All right, let's see here. I have to pass off the baton again. Let's see. There you go. Let's see. Did that work? Awesome.
There we go. There I am. Yeah, thank you. And thanks for that introduction. I'm sorry to make you read that mouthful that I have to wear. So yeah, but the short of it is I'm based at the University of Arizona in Tucson, but actually grew up in Phoenix. And so the Desert Botanical Garden is absolutely one of my most favorite places in the state. And I try to go visit it every chance I get when I'm back up in Phoenix. But so what do? I'm a fire ecologist. I've been in the field of fire ecology for about 20 years now. And I often get very kind of quizzical looks from people when I tell them what I do. But really all a fire ecologist does is, I think, in the simplest term, is try to distinguish good fire and bad fire. I think we all have a good indication of what bad fire is, especially when it has negative impacts to people, but fire can also be good, and fire is also a really critical part of a lot of ecosystems. So really my job is to try to figure out where that balance is, and where we can recognize when fire is good and where we can better recognize it when it's bad for ecosystems. So I thought I would talk to you all tonight kind of about that sort of context of when fire is good and when fire is bad, specifically for different types of ecosystems in Arizona. There we go. So some of this is pretty easy. Like I said, when fire is really impacting communities, having negative impacts on people, then that's pretty obviously bad fire. So all of the kind of scary images we see on the 10 o'clock news, throughout the fire season of communities evacuating from fire and structures being damaged or destroyed, or, and all the health implications, all of that is obviously bad fire, right? But also, humans haven't always had that kind of hostile relationship with fire. In fact, throughout the country, Native Americans for centuries have used fire for a variety of different purposes, for maintaining really critical food sources, for maintaining basket tree material and things like that, and other materials that they need for other products. And to this day, a lot of Native American tribes really consider fire to be a really critical part of their culture, their heritage, and a really critical tool for maintaining their livelihood. So even for people, fire can be good, which is why also, a lot of land management agencies sort of mimic that practice when they utilize prescribed fire. They're doing that to try to maintain healthy ecosystems and healthy watersheds. But also, different types of fire are good or bad ecologically. So fire is a really critical part of a lot of ecosystems. A lot of plants are adapted specifically to fire. Fire has the effect of kind of returning nutrients to the soil. So it's really critical and not something that should be eliminated from a lot of ecosystems. But that being said, some ecosystems, fire does not belong. Some ecosystems are really sensitive or not adapted to fire. And so in those cases, it can have really detrimental ecological effects. So how do we grapple with that? How can we kind of recognize when fire is good and when fire is bad? So as a fire ecologist, there's a couple different sort of lines of evidence that we often use to try to sort of distinguish when fire is good or bad. And one thing that we often do is we look to history. So we try to sort of understand how fire spread in different ecosystems in the past. So we'll look at things like, if fire occurred in ecosystems in the past, and if it occurred, how hot did it tend to be? What was the intensity? How frequent would it likely have occurred? So how often would you likely see fire in a system? What season would it have occurred in, and how big would fires have been? And all of that, we all kind of characterize that as a fire regime, and it gives us an indication of just a characteristic of fire for a particular area. And it gives us a good indication of what kinds of fire plants and animals in that system have adapted to, because with the idea being if plants and animals are there now, then obviously they evolved with fire of this particular characteristic over centuries. So we know that if we can kind of recreate that characteristic fire regime for a system, then it should be able to sustain that system. And there's a lot of different methods that we use to sort of try to understand this history. So one, we can look to sediment cores that are, on lake bottoms and things like that, and look at the ash and charcoal that has been deposited over centuries and age that charcoal and ash to get a sense for, how often fire occurred over the course of centuries. We can also look to tree rings. So the top left photo there is an example of a cross section of a ponderosa pine tree. And, of course, all of the rings represent annual years, and those can be dated. And then all of the nicks, they are kind of represent years in which the tree was scarred by a fire. So you can age the tree with the annual rings and look at where the fire scars are. And with that, we can kind of pinpoint, particular years, and even in some cases, particular seasons when fires would have occurred in the past. And because, a lot of these trees will live for hundreds of years, we have a pretty long record of that fire regime for an area just in the tree ring record. And then we also look at historical photos and historical records to try to get a sense for, what ecosystems looked like in the past. And then, of course, we can look to, oral traditions and oral histories to kind of understand how Native Americans used fire in the past. So those are all different methods that we use to try to kind of understand the history of fire in an area. And then we'll also look to ecology. In particular, we'll look at the plants in the system and look at what kind of adaptations they have to fire. So in some, really classic examples include, the really thick bark and the long needles of ponderosa pine, for example. That's what's shown in the top two photos there. Those are really classic plant adaptations to fire, particularly low intensity fire. So that thick bark has the effect of kind of insulating the growing tissue in the trunk, so it can be protected if the tree is impacted by fire. It'll protect it from that heat source. And the long needles of the ponderosa pine have that same effect. So they sort of insulate the bud from the heat as the fire passes. And that's really critical because the bud is where, new leaves are being produced. And so if those can survive a fire, then the tree is going to survive, and it's going to be fine with the fire. And that's also an indication of a fire adaptation, because the tree wouldn't put all that energy into that really thick bark and those long needles if it wasn't trying to withstand fire. So if we see those kinds of adaptations in the system, that's a good indication that the plants in those systems are adapted to fire, particularly low intensity fire. But we also look at different types of adaptation. So there's some plants that show adaptations to much higher intensity fire. So that's what the bottom two photos are showing. And some of those adaptations include resprouting and what we call fire stimulated termination. So the bottom right photo there, that's showing a picture of an oak tree in a chaparral system. And you can see the trunk of the tree is all charred and black. So that's an indication that it was, fire went through there, pretty intense fire, and intense enough that it really cooked the top part of the plant there. But it's able to resprout from buds that are buried underground in the root system and really insulated. Once they're in that soil system, the heat from fire doesn't actually penetrate very deeply into the soil. So they are able to survive, and they resprout after the fire is passed. So this plant is going to be able to survive even a really quite intense fire. And then the other example I have here of sort of fire stimulated termination in the bottom right photo, that's a photo of a Chihuahuan pine cone. And this is an example of a species that has this very specific adaptation to pretty intense fire. So this has what we call a closed cone. So the cone is essentially sort of glued shut with resin and other materials, and the seeds are kind of locked inside. And only in response to really intense heat does that resin melt away and the cone opens up and the seeds are released. So effectively what happens after an intense fire kind of passes through an area, it'll kill the tree, but it'll also allow the cone from that tree to release its seed and provide opportunities for new trees to establish. So that's also a good indication that that system is pretty well adapted to high intensity fire. Even if it kills off some adult individuals, it's creating opportunities for new individuals to establish. So those are kind of the two things that we typically look at when we're trying to kind of understand if a given fire is good or bad. We'll look at the history of fire in the system, and we'll look at the different ecological adaptations that plants have to fire. Now, what does this mean for Arizona ecosystem? So as you all know, I'm sure we have a variety of different ecosystems throughout the state, going all the way from desert to high elevation wet forests. And what I thought I would do is sort of take a road trip, if you will, pretend we're kind of going down from Flagstaff and driving into Phoenix and just sort of visiting all the different ecotones along the way, and talk about the role of fire in those different systems. And then in the end, I'll kind of talk a little bit about how the role of fire has changed over the last 100 years. So kind of starting out at the uppermost elevations in our wet mixed conifer forests. So these are what you would find at the highest elevations, in the San Francisco peaks or in the White Mountains, somewhat in some of the mountain ranges in southern Arizona as well, but really just at the highest elevation, and a mixture of different, Doug fir and aspen and different species. And what we know from history in this system is that patches of high intensity crown fire weren't necessarily all that uncharacteristic for this particular system. This is pretty wet forest, so the conditions aren't always ripe every summer for fire to occur. So historically, we would have only seen fires in really kind of drought conditions, which means they wouldn't have occurred very frequently. And that kind of long interval between fires allows a lot of time for vegetation and fuels to kind of build up. And when you have a high level of vegetation and fuels, when a fire does start, it tends to be kind of intense. But we know from history that this wasn't necessarily uncharacteristic, and you can kind of see one example of that from the photo in the upper left there. That's a photo from 1910 taken from the inner basin of the San Francisco Peaks area. And in the foreground, you could see pretty dense forests, lots of trees, but that kind of gray area in the background, that treeless area, that's a result of a pretty high intensity, it looks like, ground fire because there's no trees in the area. So just from this historical photo, we have a sense that, you know, high intensity ground fire wasn't necessarily uncharacteristic in the past. You know, and then if we wanted to really do a study of the area, what a fire ecologist would do would kind of try to go out to this area where the photo was taken and look for fire scars along the edge of that burn patch to also kind of see if they could pinpoint a date when that fire occurred. And we also, so we know from history that wasn't necessarily uncharacteristic, but we also can kind of look at the ecology. So the bottom photo there is sort of a more modern day look at what the inner basin of the San Francisco Peaks looks like. And you can see it's dominated by aspen. And aspen is, again, one of those species that's pretty well adapted to high intensity fire. It's got really thin bark, so and its buds are exposed, so it's pretty easily killed by fire. And it occurs in really wet areas, so fire doesn't occur very often. But when it does, it tends to kind of kill off the top portion, but then it also has suckers, you know, that can sprout from buds that are below ground in the root system, and they're stimulated to resprout following a high intensity fire. So anytime you see kind of a big aspen stand like that, it's a pretty good indication of a past ground fire, and not necessarily a bad thing. You know, it's just something that the system is pretty well adapted to. Now, if we go kind of down elevation a little bit, we would then hit our drier ponderosa pine forest, which is what you find, you know, throughout Flagstaff all the way along the Mogollon Rim and all throughout the mountains of southern Arizona as well. And this has a very different characteristic fire regime. So these forests are drier, so the fuels are drier, which means the conditions for fire to occur and spread happen a lot more frequently than they do in the wetter mixed conifer forest. So we know from history that fires actually burn quite frequently. And we know that a lot from the tree ring record. So this first photo here just kind of shows what one of those fire scars looks like. If you're ever out hiking in the woods and you see a tree that has this kind of what we call a cat face, typically these sort of triangle shapes that are all blackened in the inside, that's a fire scar. Actually, it's several fire scars. But the tree is alive, it's able to withstand that. But what happens is once it's the trunk is kind of injured, the tree will kind of grow around it to protect the growing tissue, and that's what creates a scar. And if we compare that scar kind of with the annual tree rings, we can actually kind of date when the fire occurred in the past. And that's what the second photo is kind of showing a number of scars on the trunk of a tree. And you can see this particular tree saw a lot of fire, quite a bit of fire over the course of in the 1700s. And that would have continued throughout the 18 and 1900s. And then we also know that looking from historical photos that this fire, you know, which was relatively low intensity, I mean, it wasn't hot enough to kill the ponderosa pine trees, they all survived. So that's an indication that the fire was probably pretty low intensity surface fire. It had the effect of creating this kind of classic forest condition of very open, widely spaced trees with lots of grass in the understory. And then we also know that what the fire probably looked like was something more akin to what's on the far photo there. So that's fires with really low flame lengths, not hot enough to kill the mature trees, but probably hot enough to kill a lot of tree seedlings, perhaps. So that would have allowed, for that maintaining that really open forest condition, not allowing lots of tree growth. And again, just looking at the ecology of the system, it's also a good indication that the fire, especially low intensity, fire was a part of it. We've got the ponderosa pine with its thick bark and its long needles, and not a lot of species with that fire stimulated germination or resprouting that would be more indicative of a really high intensity fire regime. Now, if we go down an elevation even further, we would hit kind of our shrublands and grasslands. So this includes, chaparral, pinyon juniper systems that you find around Sedona and Prescott and things like that. And these systems are also, very dry, very warm. And so you would think that they would have perhaps lots of opportunities for fire spread, kind of like ponderosa pine. But these systems are more what we call fuel limited because they tend to have, the species or the plants tend to be pretty slow growing because it is pretty dry. And in a lot of years, there's not necessarily abundant grass growth. And so you'll have lots of bare spaces between shrubs in the system. And that's not very conducive for carrying fire across it. So actually, in this system, fire would have been pretty infrequent historically. So occurring at any given spot, you might expect to see a fire every 30 to 100 years. But over that time frame, lots of vegetation and fuel can build up, which means when a fire did occur, it tended to be pretty intense. And this is what you see now in a lot of chaparral systems, both in Arizona and in California. They tend to burn very intensely because they're filled with shrubs that are, very high, produce really big flame lengths, and they're quite flammable. And we also know in this system too, from just the ecology, there's a lot of indication that high intensity crown fire is not necessarily uncharacteristic. So it has lots of species that resprout after fire, very difficult to kill from fire, and has a lot of fire stimulated germination, not necessarily the cones example that I mentioned before, but a lot of these shrub species and a lot of the forb species too produce seeds that have really, really hard coats that only open up in response to fire. So again, an indication that fire is kind of a natural part of the system, and even pretty high intensity fires is not uncharacteristic. Sorry about that. Now, if we go down kind of even further into our desert systems. Now this, as we all know, these systems are certainly very, very hot, very, very dry. There's lots of lightning. So the enabling conditions seem to be there for fire to spread, but what they're lacking are the fuel to carry fire. So, there's lots of bare space between all of the different plants, cacti, and shrubs. And so there's just not a lot of fuel to carry fire through a system. So historically, from all the historical evidence that we can find, there's just very little that suggests that fire was a part of these systems historically. And also, if we look at the plants, there's very few adaptations to fire. So, the iconic saguaro and in the Mojave Desert, the Joshua tree, those species are pretty easily killed by even pretty low intensity fire. So not very far adapted. And when a fire does move through these areas, it's not like they suddenly come back. These are very slow growing, and there's no indication that there's their germination or seed growth or any of that is stimulated by fire. So both of those things together kind of tell us that this is not a system where fire really belongs. Okay, so how has the role of fire changed? I mean, I think you can argue that in all of these systems, the role of fire has changed, but I'm going to kind of focus on both the ponderosa pine system and the desert system because I think, in my opinion, those are kind of the areas where the role of fire has really changed the most, at least in Arizona. So what has happened in the ponderosa pine system over the last, 100 years? Well, some of the main kind of factors that have fueled change in the system is actually fire exclusion. So, and this was driven in part by, really intense overgrazing that occurred, in the early in the 1900s with the initiation of Western expansion in Euro-American settlement, just huge numbers of sheep and cattle, throughout the state that had the effect of really kind of eliminating that grassy understory, which historically would have carried, fire through the system. So that was one thing. And then fire suppression really continued throughout the 20th century with land management agencies. It was their mission to really put out fires as soon as they started, and they became very effective at it. So, over the course of several decades and more than a century, that fire exclusion has had really profound impacts on the ponderosa pine system. So what historically would have been what looked like in the kind of the top photo there with really open stands, wide spacing between trees, turned into what looks more like the photo below it, which is like encroachment of a lot of new pine growth that otherwise would have been eliminated by frequent surface fire. And with all of that buildup of fuel in the system, what has become more characteristic are these really, really intense crown fires. And while, ponderosa pine is adapted to fire, but it's really more adapted to that low intensity surface fire and doesn't really do well in this kind of intense fire. It doesn't have fire stimulated germination or resprouting or any of those things that would suggest it's adapted to that kind of crown fire. So what you end up with is, after the fire occurs is these sort of large expanses with lots of tree mortality and no real ready way for the ponderosa pine to come back, and unless we go in and plant it. So in some cases, the forest could be lost indefinitely as a result of the fire. And in the desert systems, what has really been the factor that has changed is the introduction of a lot of different invasive grass species. So this includes red brome, buffalo grass, fountain grass. All of those have invaded different parts of certainly the Sonoran Desert, but other deserts as well. This is a problem in the Mojave Desert and sagebrush systems and others. But what happens is as the grass invades and spreads in the system, it creates a fuel bed that wasn't there before. Prior to the invasion of the grasses, there was very little vegetation that would have spread fire. But now there's quite a bit of biomass in the system that can indeed spread fire. And what that means is, just more frequent fire in these systems that historically didn't have it. And it means more species that are not adapted to fire, and a lot of really iconic species like our saguaro cacti and Joshua tree that are easily killed by the fires and aren't going to have an easy time of coming back. And then I also thought I should talk a little bit about what fire means for people too, because this is obviously another area where we're seeing just lots of change. And I'm sure you all witness it as we all do every fire season. More and more structures and communities being impacted by fire and people being impacted by fire. And really one of the main factors driving this is just the encroachment of people and communities into landscapes that are fire prone. And we call this area wildland urban interface, which is sort of where communities and fire prone areas meet. And as the population grows, as communities grow, they're gonna of course spread into these wild lands where fire is present. And it also kind of creates a negative feedback, and that when you have more people kind of interacting in the wildlands, it also means more ignitions, because people are a source of ignitions as well, either intentionally or unintentionally. Part of this is just more people being in the wildlands, but it also means more, power lines and things like that crossing the wildlands, which can start fires. So having this increased mixture of people and wildlands can create more fire, which kind of creates that negative feedback of more fire impacting people. Now, I don't want to leave on that kind of negative note. So things are changing, but I think there is reason to be hopeful. I have a lot of hope because, and the reason for that is for all of these challenges that we face and thinking about how the role of fire has changed in ecosystems, we do have strategies and tools that we can use to sort of increase the amount of good fire that we have in systems and decrease the amount of bad fire. And as you can imagine, since the role of fire in all these different systems is quite different, the particular tools and strategies that you use are quite different in different systems as well. So starting in, think about what are the tools that we could use in the forested system. Well, especially in that ponderosa pine forest system, the tools really are forest thinning, prescribed fire, and even in some cases, the management of wildfire, if the conditions are right, can also be really effective. And so by forest thinning, I mean really just mechanically removing a lot of the smaller trees that have kind of encroached upon the forest over the last 100 years. And that has the effect of really opening up the stand, removing a lot of fuel that fosters that really intense crown fire. It is really critical to follow up those thinning operations with prescribed fire, because not only does a lot of fuel kind of build up in the canopy with more trees coming in, but a lot of fuel builds up over time on the surface as well. You have just more needle growth, more logs, and all of that can fuel really intense fire as well. So it's important to also utilize prescribed fire. Ecologically, it's important for the system, but it's also important for just reducing the threat of really intense wildfire. And I thought I would share kind of a success story here, where this is how we know that this works. This is taken from a publication that was put together by the Forest Service, but it's an example of what happened in the Wildfire, which burned in the White Mountains. And what you're seeing here is that in the photo below, the bottom part of the photo is sort of the beginning of the town of Alpine. And what's in between the two yellow lines there is a fuel treatment, a thinning and prescribed fire operation that the Forest Service implemented. And what you see kind of above that line is what happened when the wildfire was moving towards the community. So, above the line that was outside of the treated area, the fire obviously burned as a crown fire, very intense, and killed all of the trees in its path. But once it got into the thinned area, what we say in fire speak is it lied down. It basically went to the ground, it transitioned to a surface fire. And that's going to have really beneficial ecological effects for that particular forest. All the trees are going to survive. And so that's a real success story. And it's an indication that those things work. Those thinning operations and that prescribed fire and those treatments really work. But not only does it work for the forest, it worked for the community, because as the fire transitioned to a surface fire, that allowed firefighters to get in there safely and protect the community of Alpine. So these things work, and they can be good for the ecosystem and also good for communities that are threatened by wildfire. Now, how about in those desert systems? What are the strategies we know? It's pretty simple. I mean, what you need to do is remove the invasive grass, right? And there's different methods that we use to do that. So mechanically, we can just remove it. But it's really just the back-breaking work of going out and pulling the grass and bagging it and removing it. That's obviously very difficult. So that's why also herbicide is a really critical tool, because it just allows agencies, management agencies, to cover a lot more ground. And that's really critical, especially when they're dealing with really, really big patches of buffalo grass. But again, we know, from looking at years of what these treatments have done is that they can be effective. So what you see on the far left here are kind of a before and after several years of treatment of buffalo grass in Saguaro National Park. And the top photo there is, all the light green is showing buffalo grass in its green state. And you can see it's pretty expansive, goes way out into the background of the photo. But the bottom photo shows what the system looks like after 5 years of continual treatment. And, to me, that bottom photo looks like your typical kind of iconic saguaro desert landscape, right? And so it really shows that those treatments, if they're aggressive and if they keep after it, they can be effective in removing the grass from the system. Now, in terms of kind of what you can do for communities, there's so much that can be done. And, there's a lot of different programs that are devoted to helping communities survive wildfires or be better prepared for wildfires. And a lot of this is what you can do on an individual level. So the diagram up on the left there is kind of from the FireWise brochure that sort of shows what you can do to your individual home to protect you from wildfire. But I really want to emphasize that it really needs to be a communal effort, because when you think about, when a wildfire is threatening a community, there's lots of complicated things to think about, like evacuation routes and making sure firefighters have ready access, and all of that needs to be done before a fire is impacting a community. And, all the community members really need to work collectively to reduce their risk, because you could do everything, follow the FireWise guidelines to a T on your own property. But if your neighbor's property doesn't do anything, then you're still going to be threatened by wildfire. So it really has to be a communal effort. And there are lots of resources and programs specifically available to help communities protect themselves and be ready for wildfire. And I thought I would kind of end with another sort of success story that I think, probably got lost in the news a little bit last summer. And the photo here is taken from the fire station in Summerhaven, which is the town on top of Mount Lemmon, just outside of Tucson. And this might have gotten lost in the Phoenix media because it was happening at the same time as the bushfire. But the Bighorn fire was really threatening the town of Summerhaven for several days. And it was a very, very nervous time for the residents there. They were evacuated, and for several days, were worried about, the town burning up, again, because it burned up once in the Aspen fire. But a lot, that community really did a lot in the last, I'd say, 15 years to try to reduce the threat of wildfire. And a lot of that was in response to what they went through with the Aspen fire. And some of the, programs that they took advantage of, I have like a couple listed here that are designed to help communities: Fire Adapted Communities Learning Network and the Wildland Urban Interface Summits, which are, designed to help people, connect people with resources and help them learn about how to protect themselves. And I leave just kind of one quote here from Sally Crum, who's the FireWise coordinator up in Summerhaven. But I think the success story here is that, firefighters were effective at saving the town of Summerhaven during the Bighorn fire. And that's certainly a testament to the firefighters. But it's also a testament to really all of the work that the community did in cooperation with the Forest Service over several years before the fire ever reached the community to make sure that they were prepared. And so the fact that no structures burned during the fire, I think, is a real testament to that, and a testament to that these programs can work. So I thought I would just end with this last slide here, because if there's one thing I'd like you to get out of the program is just this idea that that fire is good and bad, and it's not black and white, and trying to figure out when it's good and when it's bad. There's some nuance there, but it's but we're not going to eliminate fire. We need to try to, reduce the amount of bad fire as much as we can and encourage the amount of good fire in landscapes as much as we can. So with that, I think I'll stop sharing. Sorry, a little bit longer than I thought I had, but I'm happy to address any questions.
Thank you so much, Molly. We have one question in the Q&A, and I have a couple, one question and one comment I would like to make, but I'll read the one from the Q&A. Is the herbicide selective for grasses? Is it impacting native grasses in any way?
Yeah, that's a really good question. And the herbicide that's typically used, it's not specific to grasses, but they use it during a time when the buffalo grass is greened up, which isn't necessarily coincide with when the natives are greened up. Buffalo grass greens up, has a different phenology than the native grasses, and the herbicide is really only effective in killing a plant when the plant is green. In fact, it has to be practically all green. So with that timing, what they found is that the herbicide, they are really able to kind of target the buffalo grass, and it has really minimal impact on a lot of the native species.
Yeah, and that's something that I myself have learned is just the wealth of native grasses that we have here and how important those are too for our system. So I have one kind of comment. I was surprised the difference in the adaptations between an ecology of the shrubland versus the desert when, how much it changes between those two regions. I was surprised at that. But I do have a question about monsoon season and in the no soons, that we've been seeing the last couple of years. And I just kind of wonder if you have any thoughts on that, on its effect on the wildfire season and good fires and bad fires, and kind of how, is this going to be a pattern of the monsoons kind of dwindling? And yeah, just kind of your thoughts on that.
Yeah, so I didn't touch on it very much here, but of course, another contributing factor to the changing role of fire in our ecosystem is just the changing climate. So with things getting warmer and drier, our fire season has lengthened, which means fires just there's longer time period for fire to grow, and that contributes to them getting larger. In the Southwest, historically, the monsoon was kind of the end of fire season for us. We typically get a lot of our fires in May and June when you would get lots of dry lightning strikes, or it's sort of the starting of monsoon, but not necessarily a lot of rainfall. And then once the monsoon hits, that's typically, in the historical record, that's when you see the fires kind of stopping.
Right.
And with what we saw last summer, one reason that some of these fires got so big is because we just didn't have that monsoon moisture. And that certainly is a concern going forward if that kind of trend continues. I'm not a climatologist, so I can't really speak too much to what we expect for the monsoon in the future. But if that trend continues from a fire perspective, it's very concerning.
And just kind of following up on that, kind of looking ahead, and I know from what I've read before on climate-wise, are there any other comments looking ahead about climate, anything else, the Sonoran Desert? I feel like it's the area in which the Sonoran Desert exists, I almost feel like it's shrinking or something. And I wonder if, you have any comments on just, the 10 years that are to come, and any final thoughts on that before we log off?
I think that I agree. I share the concern with the Sonoran Desert, especially, what would happen with the bushfire last year. And if you drive around the Cave Creek Complex fire, which I think is old now, you could see that system is not coming back as Sonoran Desert. I mean, these are just so slow growing. So it's, once the fires occur in these systems, it's hard to think that they're not lost forever from my perspective. So that is concerning, and anything that we can do, I think, to limit the amount of grass growing in those systems is really critical.
I think you kind of just, hit the nail on the head there, is that there is a lot we can do as residents to protect our own properties. I did put a link to the FireWise program for the people that are here in the room. It's a great program for the communities to be more fire aware and prepared. So I definitely recommend looking at that, especially if you are sort of in North Phoenix area, those Cave Creek area. Those folks saw a couple of fires last season. But yeah, the invasive species are a big challenge that we have here, and one of our big focuses. So I'm excited that you're saying that that's something that we really should prioritize, because it's something that we are really taking a look at ourselves. So yeah, is there any other, if there's any other questions, just 1 more minute, 2 more minutes to put those in the chat. But thank you so much, Dr. Hunter, for this. I think I learned a lot just in terms of there is good fire and there is bad fire, and we just got to focus on eliminating those bad sources of fuel so that we can eliminate those bad fires. There is also, I'm going to put a link in the chat to our Desert Defenders program, which does focus on mapping invasive species, removing those invasive species from our parks and preserves, and also just that general education about removing stink net on time and removing fountain grass and all those bad plants on time. Any other final comments, thoughts?
No, I'm glad you mentioned that. And I will just say that I think in both Tucson and Phoenix, there's lots of great community efforts and community groups that are really focused on eliminating buffalo grass, and they work really hard every weekend to go out and pull. And so I think there's lots of opportunities to get engaged if it's something people are interested in.
Yeah, well, thank you all so much for joining us. Thanks again, Dr. Hunter. This has been recorded, so if you, I know Anne had to go, for example, but if you want to look at it again, we'll have that up on our YouTube in a couple of days. Also, don't forget to join us for our talk on May 26th with Dr. Ben Wilder, who actually focusing a lot more on invasive grasses and invasive species and how those affect the Sonoran Desert and the relationship to wildfire. So we're looking forward to that one as well. And yeah, thank you all so much for joining us.